Okay, I'm back again. Here we have another problem. The average salary for public school teachers. Okay, I'm going to mark some things up here. The average salary for public school teachers for a specific year was reported to be $39,385. A random sample of 50 school teachers in a particular state had a mean of 37,864 and a standard deviation of 5,975. Is there evidence that alpha is 0.025 to conclude the mean salary of public teachers is less than this? Okay, so feel free at any time to pause the video and work the problem yourself and then turn it back on. And as I put the answers up, hopefully, or the solution up, hopefully your answer will match what I put up. Okay, so let's look at this. We start out with the average salary for public school teachers for a specific year was reported. This number was reported. $39,385. $39,385. Now, what happened is we actually did our sample and got less than that. So we think that the salary is really less than that. This was reported, and we think it's less. We're looking for evidence. Is there evidence that that is true? So that's our alternate. And to fulfill the whole number line, I do that. Now, what type of test is it? Well, you go to the flow chart, and I noticed here we had sigma. If sigma is known, right there is a z-test. Sigma is known, so we do a z-test. And what type of tail? We've got a lower tail problem. So this is a one tail. I'll draw a little picture here. There's our tail right there. We're looking for a number that's significantly less. We want to see if this sample number right here is significantly less than what's reported here. So what's the next step? Alpha. So one tail test. So alpha is whatever we're given. 0.025. Degrees of freedom is infinity because this is a z-test. We reject if z. It's a one-tail test, so these two symbols will match. And I've got to use these two numbers. Look that up on the t-table. 0.0525 at the top. Infinity, which is the bottom row, 1.96. And you can add a 0 to the end of that if you like. Now, that number goes right here, 1.96. Now, something that you're going to have to do. This is a lower tail test. Whenever you have a number on the lower side, whether it be half of a two-tail test or a lower tail test like this, you're going to have to remember to put the minus sign there, and you're going to have to remember to put the minus sign there. Let me step back. When it's a lower tail test, you got to put those two minus signs. Now we'll do the computation. Let's get these numbers. This number is always this number. Now, what was the actual mean we got? This number right here, 37,864. Standard deviation, 5,975 divided by the square root of how many teachers? 50. And then make your computation. I got negative 1.8. Now I'm going to use a red pen so this will show up. Negative 1.8 lands right there. It's close to the rejection region, but not quite. This number is right there. So we failed to reject. There was not evidence to accept H1 is true. And so as far as the z-tests go, I've given you a lower tail, an upper tail, and a two-tail. Only three things there can be. Okay, let me pause this, and I'll see you in a little bit.